Reach out to get to know us better, because we definitely want to be interfacing with more developers, more system integrators here in North America. So without a repeat of the introduction here, what we're going to do today is we're going to give you a short KEBA introduction to who we are, the robotic solutions in itself, which includes how CODESYS is interfacing with our control system around robotics. And then we'll get into the actual Cognibotics application and how we help this customer be successful within robotics with our capability and CODESYS. So KEBA has actually been around since 1968. We export about 87% of the products that we make. Therefore, we're located in 16 countries with 26 locations, and we have over 500 million euros in sales each year. But the two important things that really we want to emphasize here for today is the fact that we reinvest our revenue at a rate of at least 13% in R&D each year, because this is what helps us live by our logo under KEBA, automation by innovation. So this is really what brings us together as a team and a company. And the second thing is the fact that KEBA is 2,000 employees strong, and the combination of those two things allow us to do a lot of nice things in the market, which you're going to hear about today. All right, in terms of robotics itself, I apologize, I have to move my screen a bit here. We've shipped about 110,000 robots worldwide that run on our technology. We've been involved specifically around robotics for 30 years. In just this fiscal year, we believe that 23,000 robots have been shipped with KEBA technology on board. We partner with international robot manufacturers and process experts, which we'll share a couple of those in the next slide. But the major thing that really motivates us is when you look at the automation and factory floor today, there's just a lot of challenges around mass customization, individualization, high mix production environments, labor shortages, and how operators are interfacing both with machines and robots today. It really makes a challenging environment, and we believe that what we are doing is going to help that. And so we continue to invest in robotics and expand our capability and technology in robotics. So here's a couple, short list of our global partners, and you'll recognize a few of them depending on where you are, but we partner with a lot of major manufacturers of robots. So Yaskawa, Kawasaki, Kamau, Denso, Hitachi. So, a lot of different ones. We also interface with automation suppliers like Rockwell and Mitsubishi, and we also supply some of the major OEMs in very specific markets, like Dur that makes paint robots, and Trump that does laser processing systems, and Angle that does plastic injection molding. So KEBA is basically a technology powerhouse to a lot of major brands. But we certainly want to continue to educate and share with North America who we are, probably a little bit more than maybe I think people were aware of. So just to give you a quick run through of what KEBA makes, one of our major products is our HMIs, with both stationary and mobile HMIs. So in today's environment with robots and operators having to be very highly mobile, and having to interface with many control systems. This is why we think it's been very popular for customers to start using mobile HMIs, and KEBA has the only kind of solution for that has properly gone through a safety rating process so that it can operate safely with both robots and machines. So the other thing is we do produce controllers. These controllers have machine control available, motion control, robot control, and safety control. And within that controller platform, you can connect I/O modules, servo drives, motors, and really be able to interact with all those platforms from our central control system. But one of the principles that we like to really adhere to is an open control platform, and that's another reason why we use CODESYS, and we try to work with it with a lot of industry standardization boards, and really make our platform very accessible for customers and very open. The next elements kind of go into some of the principles that we do around our business unit. So we have industry know-how groups, which Michael is one of them that represents our robot group, where we have a plastics group, a CNC group, a laser group. So this is the expertise that we continue to build inside KEBA. But in all these situations, whether it be product or industry solutions, we're always integrating and making sure we're up to the safety standards, and safety is included in all those solutions. And we're also adding digitalization to those solutions as well. And that can include things like simulation, IoT capabilities like OPC UA, and even condition monitoring. So we're really making sure that we're making sure our solutions are as smart as possible. All right, so what does that mean in terms of software and how the kind of the product portfolio of KEBA? Within our software suite is CODESYS, but in conjunction with CODESYS, we have a lot of support programs that kind of build it out to a complete suite. So there's a configuration capability in our software that helps you configure which targets and devices, controllers, motion products, sensor products, networks. It allows you to configure that. The visualization, which is building user interfaces, the actual control programming, which as you'll see will include CODESYS. We have a safety programming, and we have the drive and motion control diagnostics, along with simulation and real-time digital twin type capability as well. And once again, you'll be seeing that very shortly. Okay, in terms of our robotic solution, what are we providing? We have a controller and drive rack all in one, as you see in the image. The first module is the control module, and then we have a central power module, and then you have modular drive units. And we can connect these to motion axes. We can connect these to robots. And this allows us to control those robots, essentially control the safety capabilities and monitoring across that robot. It allows us to teach in the moves of the robot and the sequencing. And it also provides the engineering tools around simulating a robot and going through different type of operation scenarios. So within this architecture that we're showing here, it also provides better scalability for the customer. So most type of robot controllers, you get one big box, and that one big box is going to control one robot. And sometimes you can network those robots together. But with our solution here, you can actually just add on additional drive modules, and you can control multiple robots within the same software project. And it just allows a lot better functionality, coordination across the robots, even coordination with the machine and the motion systems. And you can control multiple robot types. So it does provide a good, flexible, scalable solution for customers. From an adaptability standpoint, we really focus on our software capability to be ease of use. We're implementing more and more capabilities of what people are calling like programless code, or more visual-based programming type of capabilities. So we continue to build that out. We have multiple ways to interface with both products that are on the machine through control networks and systems above the controller in the IT space. and also being able to support multiple languages and multiple user interfaces within our software package. All right, so what we're going to get down into right now, and this is going to lead into Michael's presentation, is the key capability of KEBA comes down to what we call our flex core technology. And what we have is a Linux real-time engine that we then have many different types of modules that can feed into this real-time Linux engine for machine control, robot control, and CNC control. And this is where CODESYS comes into play, because CODESYS fulfills that PLC block that you see in that diagram there. And so with this here, you can control up to 30 different types of robots, or even custom configured robots as well. And you can program and control up to 16 robots in one controller, which is really a phenomenal advantage that KEBA has. The next part here is safety, because whether it's the machine safety or the robot safety, the motion safety, we really cover the complete spectrum, and we actually bring those safety systems together so that if you have multiple robots or motion axis or machine, it's a cohesive and coordinated safety system. So we provide safe motion in terms of force, speed, position, acceleration, recovery. From a robot perspective, we support safe area functions, safe planes, safe TCP actions, and then we can interface those two systems, like I said, together so that they're a coordinated safety system. So once again, safety is a big part of what we do in all our technologies. All right, so this is the part where here I'm gonna stop here, and I'm gonna let Michael take over, and he can show you all the fun stuff.
So welcome from my side as well, from the other side of the pond. I'll give you an overview of the architecture, somewhat more in depth, how our robotic systems really look like. As Daryl mentioned, we are running typically on a Linux system. We use a real-time extension to be precise and in time. And a lot of base services that all our runtime systems take advantage of for data exchange, for communication, for diagnostics, for security, and so on. On top of that, our customers, the OEM, can write this PLC application in the IEC languages using the CODESYS platform. And right next to this runtime system, there's the robot control system that we provide. And we can have a somewhat deeper look into what this robot control system does. It consists of three larger blocks. One is a motion control system that actually does the interpolation, the path planning, and the path execution. Then there's a program interpreter, which runs independent of the PLC application. And this executes basically robot programs. They could be used for other machine functionalities as well. And there's an application layer that allows you to define the language that we provide. Basically, we have this end user level. If you're familiar with a standard industrial robot and languages like Rapid or KRL, this is a comparable language. The differences there compared to a standard industrial robot is that actually you can, as an OEM, you can change the application layer a lot. You can change the types of commands that are available. You can add commands that integrate your process technology, and you get an integrated representation of robot motion and process settings. Also, you can integrate your own transformation within the motion control. And you can also have all kinds of adaptations to the interface between PLC side and the robot control side. And for the high-end geeky ones, there's of course a real-time C++ environment available for integrating deep technology on the same platform. This can also be accessed again from the PLC side. Also the C++ part can interface to the robotics. So many functionalities available. All of this comes with a lot of APIs to access from outside, from higher level systems or HMIs. We are right now in the process of switching to web-based secure APIs. So how does this compare to a regular PLC plus industrial robot setup? Typically, that's how industrial robots are deployed in most of installations. There is typically some kind of field bus or network interface between the machine PLC and the industrial robot controller. We enable a more integrated approach where the machine control, the robot control, and the process control can be done on a single integrated platform. What are the challenges of the common approach? On the one hand, you need to synchronize data and you need to manage data. For example, if you look at clouds or tool environments, you have to manage two, they have to be consistent. All the data coming from a part information from your ERP system need to influence both parts, both the PLC part and the robot part, and they might have very different interfaces and very different access possibilities. In our system, you have one single access for all the data, for process information, for the robot parts, as well as for the overall machine works. And this is really integrated and unified, much easier to handle. If you're using an industrial robot, you get kind of a black box. It's not just a closed box, as Daryl explained, it's also pretty black. You have some defined interfaces and it does what it does. If you want to influence the behavior, you have a hard time. On our side, you have full access and full control on the behavior of the robot. You can change in the update cycle of each server drive all kinds of data, and you can really integrate well between the process or the machine workings and what the robot is doing. Typically, you have some predefined technology packages on standard industrial controllers. They have some defined possibilities, functionalities, but basically everyone can buy this. You are not able to differentiate yourself by providing some better welding technology or better packaging technology or better whatever technology. You just can use what the robot manufacturer does for you, and everyone else can use exactly the same thing. On our side, you can create your own technology, your own outstanding differentiated solutions and technology that make you really stand out of the crowd. If you talk to people that integrate industrial robots in some more complex installations, the operators often have quite a hard time to get this running. The user interface, user experience is basically split in multiple parts. They look different, they feel different, they behave different, and getting everything synchronized, working, operational, especially in some exceptional situations, is really something hard. On our side, this comes from this unified data model. Also, the HMI is consistent, and you can have a really easy to use environment. And this really brings out the power and the flexibility of robotics, because your operators can really handle it and use it easily. Engineering and after-sales processes on two systems is sometimes really hard. If you want to simulate things, if you want to service things, you are dependent on other sources within our system. Everything is just one single system. You can simulate the entirety of the solution. You have full access to all the process data, diagnostics data. If there are messages from the robot, you have them in the same message buffer as your process messages. It's all integrated and easy to handle. And of course, you're logged into the vendor's portfolio. If you have certain applications that would benefit from a customized robot, then you are basically not able to use your favorite robot vendor's controller on your customized or adapted robot because they just don't support it. In our system, we can have interfaces to standard industrial robot arms as well as your customized application-specific robot. So many more opportunities and possibilities to make life easy, flexible, and all the processes much simpler than in regular installations. So what does this all look like? I'd like to give you a live demo. The entry point for an integrator typically is KStudio, which is our environment for programming PLCs, the PLC part and the robot part, and handling the entire system. So if you find this somehow familiar to what Kevin presented, this is not happening by accident. This is based on the CODESYS platform. If you're familiar with CODESYS, you will find it very easy to start here. You can program just your PLC code as you're used to with many other systems. What we have integrated here is a robot configuration. So you can define what kind of robots you want to run on your system. You can, as Daryl explained, install up to 16 robots on a single controller and define all the parameters that are required for this robot. For example, the dimensions, the type, the assignment between servo drive and robot axis, also dynamic properties of your robot, such as center of gravity, inertia moments, and so on. So you get an object, which is your robot. You can have all kinds of drives and peripherals, IOs, interfaces to higher level control, and so on. From how is the robot operation and PLC interacting? There are several libraries that allow you to interface between the PLC part and the robot part, and also the update of the robot, of the motion planning, and of the program interpreter is controlled out of the PLC environment, which means that you have full synchronicity between all the real-time data in your PLC and the robot. So if you want to, for example, have a moving object, you can process the movement, read it out of some sensor, and put it into the robotics kernel within the PLC application. Also, the operation of the robot is controlled fully with some libraries. So this means that you can choose and define your own states, your own modes of operation. There's lots of libraries involved and access to that. And there's some standard interfaces already present. If you need more, it's very easy to add more information and more data exchange between the PLC side and the robotic side. What else did we integrate? There's also a program interpreter, program editor for our language, the Cairo language, which is fully integrated in the environment. And you can write your robot programs right in the KStudio environment and download this to the robot controller itself. So if you're done with configuring, programming your process part, programming communication, you just download the entire project containing configuration, PLC code, as well as some programs. Either you download it to a real controller, or of course we provide a digital representation, a simulation of a controller, and that's running on my laptop. And I can show you how this looks like. Basically, we have an environment that represents our teach-in system, our mobile handheld device, as well as a digital twin, a scope that has some 3D simulation, 3D model of the robot, as well as all the possibilities to analyze all kinds of signals that happen within the PLC side or on the robotic side. We can now look at such a gyro program here. I can just open this here, and then we can start executing it. And you see robot movement as well as process data. In this kind, it's the current path speed of the TCP, all integrated in this view. And this is typically how OEMs are developing their technology and their technological solutions within our environment. So you can see here, for example, the path of the TCP available for later analysis. This can also connect to a real-life controller, and then you can do the same when operating a real robot as well. Here you can see this gyro code. This provides all the necessary teach-in functionality. You can jog the robot, you can teach the robot. This looks very much like a standard industrial robot, but it's highly customized on the same side. So let's continue here. Just to demonstrate what our customers are typically doing, I would like to highlight this story of Cognibotics, which I find quite interesting. Cognibotics is basically a technology company founded around 10 years ago, and they have lots of robotics know-how, and they came up with a few good ideas about new application-specific robot types. And one of them is this HKM with the main slogan of reach and speed. And about a year ago, they contacted us and said, we have this very nice robot, but we really need an industrial, mature, capable robot controller. And we were the #1 choice. So what is this HKM good for? Basically, it's addressing intralogistics, especially handling of single items. Intralogistics, if you look at this, online e-commerce is growing, online orders are growing. The shipment of pallets out of warehouses is reducing a lot, and single shipments are increasing a lot. This means that many, many more orders have to be processed, and this needs automation. But if you look at the state of the art of robots, I think that's already common in many warehouses. The first choice that many people are doing, just add a cobot here instead of this person. But when people do that, they find out that the cobot is so slow compared to some trained and quick human, that basically the business case is not there, and the performance of the entire warehouse is decreased. You could use industrial robots. The integration is getting more costly because you need all kinds of safety equipment around it. industrial robots are a bit faster, but compared to humans, basically there's no way. Human flexibility and performance just outperforms any approach with a standard robot so far. So when you look at robot types, there's robot arms ranging from your little 4 kilo 600 millimeter to a series of cobots to very large robots that can be used in warehousing. And if you have some palletizing applications, that's basically the right machines of choice. Also, if you have large orders, these gantry systems are quite common. In the industry, especially in packaging, pick robots are quite common, but they lack the required reach if you go into logistics. So the pick rates would be good, the speed would be good, but the range is not there. And the HKM just fills this gap and extends the available portfolios by combining very large reach of a radius of 3.6 meters with a payload of 7.5 kilo with very high speed. So the solution of Cognibotics consists of a robot, a vision system, and the respective tools, and to complete such an item handling package. Now this RVT combination can be easily integrated in all kinds of interlogistics systems because of this large reach. The vision system is driven by AI and is typically automatically learning how to grasp different items. It's also improving over time, and so this can give a very reliable system. The tools, of course, the performance of the robot depends, or of the entire system depends on the right tools, especially what kind of totes you're using, what kind of parts you need to handle, pieces you need to handle. You need to be very flexible on the tool side as well. Key performance figures that are now able, pick rates are in the order of 2,000 items per hour. This means that in 1.8 seconds, the entire system identifies a new piece, picks it up and places it to another position. The pick rates, successful picks are above 99%. And what is our part in all of this? Basically, it's an integrated control solution consisting of a CPU module, including Intel Celeron CPU, as well as a safety module. You need to still take care of functional safety, and that's included in the system as well. We have the servo drives and the supply module available, and there's a central encoder interface to interface to all the robots' axes. Software, there's exactly the Chemotion robot control system that we have explained before. Cognibotics has integrated some C++ code with their own proprietary technology into the system in this real-time C++ part, and also interfacing with our motion controller. And of course, there's a mobile teach pendant for commissioning and teaching positions. The key features, transformations are integrated by Cognibotics. Also, some motion control optimization is integrated. Vision and tool changer, that's a typical task of CODESYS. We use the flexibility and the versatility of CODESYS as a central platform for data handling with the internal and external world. Also, the interface to warehouse management and the main plant controller, a typical task that is implemented in CODESYS. And this is also something where the easy programming of CODESYS is of high value. And of course, functional safety is mandatory and integrated in this entire system as well. So how does this look like? So the robot is some kind of hybrid between, and that's why the name is called hybrid kinematics, between a delta robot and a scalar robot from some of its features. So it has parallel moving arms, but it does not require the full envelope of a delta robot. The key design feature is that all motors, all heavy elements are located at the center and are barely moving. So everything that's moving is very lightweight. And this is why this is able to achieve this performance data. Also, the tool changing system is pretty clever. It can change tool very quickly, and that's crucial because of the large variety of items and item types that are typically available in a distribution center. And the key feature that is highlighted here is this large operating area, and this is very useful for intralogistics solutions. So this seems, and is a typical example for that, that there are still opportunities for application-specific robot types. And I hope we can inspire some of the participants to think about what can be done with either a customized robot type or by using standard robot mechanics and integrating processes much better than in the regular way. So what's the summary and conclusion? With this deep robot integration, you can integrate the machine operation, the robot operation, and technology control on one platform. It's highly customizable for specific requirements, and you can achieve data consistency across the entire project and handle projects very efficient and very reliable across the entire life cycle, from basically from the bidding phase down to after sales service. So what's the benefits for the OEMs? Our OEMs are very flexible and can have lots of opportunities to integrate their own core technology together with the flexibility of our robotic systems. Very efficient and consistent project realization. They can have a unified system both for using standard robots as well as application optimized robots, and many of our customers do that. They have certain applications where they use standard robots and other applications where they use optimized robots. And of course, as a key, our OEMs can differentiate from a normal system integrator. They can do much better than people on Earth. They can focus, they can differentiate, and they can provide extra value for their customer groups. And what's the end user's benefit? They get a unified and consistent operation of their systems, and this provides lots of ease of use compared to combinations of several standard products. And so the promise of introducing robotics is really there. This true flexibility, end users can master new products and parts, and so this is much easier to handle. Also, automation can go even further, and data from customization, from individualized products can be fed into the system and influence the production directly and consistently. And so you can really build lot size one with our systems. And of course, this is always the goal. We want to provide reliable systems, highly efficient systems that allow overall highest overall equipment effectiveness and very low cost per part. so that the end users of our customers have full benefit of flexibility combined with reliability and low production costs. So we hope that gave you some impression about the possibilities and potentials of integrated robotics, and I would like to thank you very much for your attention.